Hello and welcome. Today we're going to do something a little different. Instead of looking up at the stars, we're going in the complete opposite direction, straight down. We are going to peel back the very ground we stand on and discover what our world is really made of, from the surface all the way to its fiery core. Seriously, have you ever just stopped and wondered what's right under your feet? And I don't just mean, the pipes or the soil. I mean what's thousands of kilometers down, right at the very heart of our planet. Well, today we're going to find out. The simplest way to picture our planet is to think of an onion. It's not just one solid ball. Nope, it's made of all these different concentric layers, one wrapped inside another, and each one has its own totally unique properties. So our journey begins now. We're going to start peeling back those layers one by one and head straight for the center of the Earth. Our trip down is going to take us through three main zones. We'll start right here on the surface, on that thin outer layer called the crust. Then we'll push through the enormous middle layer, the mantle, and finally, we'll arrive at the super hot, high-pressure core. Okay, get ready for this because this fact is kind of wild. The crust, the entire world we live on, every mountain, every ocean, it only makes up 1% of our planet's volume. Just 1%. The vast, vast majority, a massive 84%, is the mantle, and the core takes up the last 15%. So let's talk about that tiny 1% we call home. The crust. It is by far the thinnest of all the layers. Think of it like the delicate skin on an apple. That's it. That's the solid ground beneath all of our continents and all of our oceans. But, not all crust is created equal. The continental crust, which is what makes up our land masses, is about 35 kilometers thick. It's mainly made of silica and alumina, which gives it the nickname SiAl. Get it? Si for silica, Al for alumina. But the oceanic crust, under the oceans, is way thinner, only about 5 kilometers, and it's made of silica and magnesium, so you guessed it, SiMa. All right, once we push past that super thin crust, we enter the mantle, and this layer is an absolute behemoth. It extends down a staggering 2,900 kilometers. This is where that massive 84% of our planet's volume comes from. It's just huge. And our final stop is the core. This is the very heart of our planet, a giant sphere with a radius of about 3,500 kilometers. It's made mostly of nickel and iron, which is where it gets its scientific name, knife, Ni for nickel, and Fe for ferrous, which means iron. And the temperature and pressure down here? Just completely unimaginable. So how impossible is this journey in reality? Well, to reach the center, you'd have to dig a hole 6,000 kilometers deep from the ocean floor. Now think about this. The deepest mine humans have ever dug is only about 4 kilometers deep. So yeah, the center of our own planet is a completely unreachable frontier. Okay, so while the deep interior is pretty much out of reach, we can definitely explore the surface. Let's zoom back out to that crucial 1%, the crust, and ask a really basic question. What is the ground we stand on actually made of? The answer, in a word, is rocks. A rock is basically any natural mass of mineral matter that makes up the Earth's crust. They come in all different colors, sizes, and textures, and they are, quite literally, the fundamental building blocks of our entire world. And all of these rocks fall into three major families: Igneous, Sedimentary, and Metamorphic. And here's the cool part. Their names basically tell you their stories. Igneous comes from the Latin word for fire. Sedimentary is from the Latin for settle down, and Metamorphic comes from Greek, and it means change of form. See? Fire, settling down, and changing form. Let's start with igneous rocks, the ones that are born from fire. When molten magma cools down and solidifies, it forms an igneous rock. Now, if it erupts as lava and cools really fast on the surface, we call it an extrusive rock, and it has tiny, fine grains like basalt. But if that magma cools super slowly deep inside the crust, it's intrusive, and it forms large grains like the granite that's used to make grinding stones. Next up, sedimentary rocks. Now these are formed in a totally different way. They happen when other rocks get broken down into little tiny fragments called sediments. These tiny particles get carried around by wind or water, they settle down, and then, over millions of years, they get compressed and hardened into distinct layers. Sandstone is a perfect example of this. And our third family, metamorphic rocks. These are the great transformers of the rock world. They start their lives as either igneous or sedimentary rocks, but when they get subjected to incredible heat and pressure deep inside the Earth, they completely change their form. For instance, clay can get transformed into slate, and limestone can become beautiful marble. Now here's where it all comes together in this beautiful, elegant way. These three rock types, they aren't just separate categories. Oh no. They are all part of a magnificent, continuous process of transformation known as the rock cycle. So, let's trace the journey, shall we? It all starts with that molten magma deep inside the Earth. When this magma cools and turns solid, poof, you have an igneous rock. But the story doesn't stop there. That igneous rock can get broken down by wind and rain into all those little sediments. Those sediments then get carried away, they get deposited, and they get squished together over a long time to become a sedimentary rock. And the cycle continues. If you take that igneous rock or that sedimentary rock and you subject it to immense heat and pressure deep in the crust, it doesn't melt, it transforms, it becomes a brand new metamorphic rock. And to complete the circle, if that metamorphic rock gets pushed even deeper and experiences even more extreme heat, it'll melt completely, turning right back into molten magma. And from there, well, the cycle is ready to start all over again. It is a truly never-ending story of creation, destruction, and change. So, why does all this geology matter to us? I mean, these are just rocks, right? Well, they're not just abstract concepts. They are the literal foundation of our civilization, and they are all around us, every single day. Think about it. We use hard rocks to make our roads, our houses, and our big city buildings. We use specific rocks like granite for tools. We even use little stones for simple kids' games like hopscotch. And, maybe most importantly, we use them to build incredible monuments that can last for centuries. Just take two of the most famous landmarks in India. The incredible Red Fort is built from red sandstone. That's a sedimentary rock. And the world-famous Taj Mahal? It's made of that beautiful white marble, a metamorphic rock. Our history is literally written in stone. So, the next time you walk outside, just remember, the ground beneath your feet is so much more than just ground. It's the product of an epic journey through fire, pressure, and time. Every single rock has been on this cycle for millions of years. Which makes you wonder, right? What story might it tell?